Welcome to all. Question number 24. From today onwards, I am going to cover lamina where multiple components are there. Maybe rectangle, triangle, right angle triangle, sometimes triangle in general, sometimes isosceles triangle, then trapezium sometimes, then semicircle, circle, quadrants, etc. So, this all purpose is to see that everything is clear. See, if I take class only for practical knowledge, for structural design, such sections are not required. But so many people, they are depending on academic requirement also on this class or competitive examinations where this much complication will not be given. Simple, see, this much can be given, only this much. So, I decided to completely cover. Maximum number of questions I will cover. Then everything will come once again later when I go to moment of inertia. So some of the question I will keep pending because when you go for moment of inertia, again you have to locate centroid there. Okay, further I will give details. 24. Locate centroid for given lamina, all dimensions in millimeter. See, a semicircle of radius 60. This is 200. This is semicircle of diameter 175. This drop is 110. See here, this point comes up to here, but this downward starts from here. These are not same vertical lines. See, difference is there. From here to here, the left distance gap is 30 given. This is a given sketch. Okay, now class divide into 5 parts. See correctly, roughly put here. See correctly observe here. 1, it's a semicircle. See, 2 rectangles, see, 2 rectangles, 2 semicircles, and 1 right angle triangle. Okay, 1. See here, this way, up to here and here. See, this is the rectangle. 2. This is the right angle triangle. 3. This is semicircle. 5. This rectangle, one more rectangle is here. See, that rectangle, see here, this rectangle goes up to here. That rectangle comes up to here. The gap is 30 mm. See, you can make out here. See, this rectangle extends beyond this point here. So that gap is 30 given. Okay, now, reference axis all I will write later. Now do one thing. Draw a neat sketch. See, I written here. Somewhat to scale. 120 dia. Dia 120. See, I told already, we always want diameter. This I told you. So diameter is, see, radius is 60. So for the semicircle, dia 120, but this distance is radius equal to 60. See, this is radius 60, 120. This rectangle is 200. This triangle is, see correctly now, this is diameter is 170. See correctly here. This diameter is 175. But the triangle comes from here. So if this is 175, see here, this is 175. 175 subtract 30. See, from here to here is 175. Subtract 30, you get 145 is the base of the triangle. Then height. If the diameter is 60, radius is 60, see, the radius 60 means diameter is how much? This is a diameter. 120, see, project here. 120, this also 120, common. For this rectangle and this triangle, height is 120. This rectangle, height is 110. 110. This semicircle, they told diameter is 175. Okay, radius not required. So this is 175. But this distance is radius, half of 175, 87.5. You can make a note here. How you got 145? You make a note there. From 175, subtract 30, that's how we got 145. Then, over 110, 87.5. The total from topmost edge to bottommost edge is 120 plus 110 plus 87.5 is 317.5. Lengthwise, see here, 60 plus 200 plus 145. 145 plus 60 is 205. 205 plus 20 is 405. So from here, extreme end to this extreme end is 405. I want some space here. See, that 405 is up to here. From here to here, I will enter later, 405. Now, everything is ready. So I will go for the table now. This all I will remove. This I will remove. Everything I will remove now. Then start calculating. Those who are serious, make a note. I will dictate. Let us consider reference axis OX and OY for locating OX for Y bar and OY for X bar, or let us consider reference axis OX and OY with origin O at the bottom extreme corner. See, bottom extreme corner O. Now this way we will measure X, this way we will measure Y. Make a note. Then there is some car siren going on. Okay. Then some more note you have to write. Let X bar be distance of centroid for the entire lamina from OY axis to right side. Why? X is going this way. And Y bar, red color, be the distance of centroid of the entire lamina in the upward direction from OX. Then we have X bar equal to A1 X1, A2 X2, A3 X3, A4 X4, A5 X5 divided by total area. That is A1 plus A2 plus A3 plus A4 plus A5. Same way, Y bar from reference axis equal to A1 Y1, A2 Y2, etc. up to A5 Y5 divided by total area. Write each and everything. Now, part 1, 2, 3, 4, 5, all I explained. Now see correctly. Actually, I am rubbing out now. Those people who find difficulty for centroid, see here. This is 2 rectangle, exactly midway. See, 200 here, 200 by 2, 200 by 2, 120 here, 120 by 2, 120 by 2. If not clear, you cannot study anything. Fourth one, base is 175. 175 by 2, 175 by 2, 110 by 2, 110 by 2. Okay. Triangle, see, centroid will be this side and this side. See, divide into 3 parts, divide into 3 parts. This is G3. See correctly, right here. If you want, this is 1 by 3 of, how much it is? Base 145. 145. And if you want this distance, it is 2 by 3 of 145. I am removing it. And here triangle, see, this is 1 by 3 of 120, and from here to here is 2 by 3 of 120. Okay, write that one. Then for semicircle, centroid is here, see. This way, exactly midpoint. 175 means this way 175 by 2. But this way, this distance is 2 times diameter divided by 3 times pi. Here, this way exactly center here. But this way is 2 times diameter divided by 3 times pi. If you want, write that one. Okay, but I should remove actually. Okay, let it be there. Later I will not write this way. Okay, start now. A1, semicircle, pi by 8 of diameter square. I wrote the answer. A2, 200 into 120. Answer is there. A3, half into 145 into 120. Yes. A4, 175 into 110. A5, pi by 8 of diameter is 175 square. Over. Areas are over. Find the total area. Then X this way. See. from here, this way, to here, centroidal distance, x1 is 60 minus, why I took, oh, this is wrong. It is 6, I made a wrong entry there. It is 60, that is for second one. Okay, no problem. Answer will come same. It is 60 minus 2 into diameter, 120 divided by 3 pi. Okay, I thought for rectangle, then forgot that it is semicircle. Okay, no problem. I can make out 60 minus 2 into diameter is 120 divided by 3 divided by shift pi. Actually, I know the answer, 34.535. I noted down there, everything I noted down. 535 millimeter. Okay. x2, 60 plus half of 200, 160. x3, 60 plus 200. Be careful, from here first come up to here. 60 plus 200. Don't see this one. 200 plus 1 by 3 of 145. 308.333. G4, 60, don't go there. See, you have to come here. 60 plus 170. How I got 170? From 200 subtract 30. 170 plus from here to here is half of 175. Then G5. Again, 60 plus 170 plus this way center half of 175. And remember, this G3 is slightly this side of G4. It is not same vertical line because, see, this is some other value. Anyway, you can make out later. This is slightly to this side, but does not matter. Okay, all x are over. Go for y calculation. Start. Figure number 1. From here, 87.5 plus 110 plus exactly midway plus diameter is 120 by 2. Next, figure number 2. 87.5 plus 110 plus once again 120 divided by 2. Figure number 3. 87.5 plus 110 plus this is 1/3 of 120. Figure number 4. 87.5 plus 110 divided by 2. Last one. From here to here is 87.5. See, 87.5 radius minus 2 times of diameter divided by 3 times pi. Okay, you got all the y values. Now, what you do is enjoy. I write here. Now, you should enjoy it. Now, enjoy. Enjoy. Take your calculator. Show systematic calculation. Get x bar. See, don't write waves. You show the calculation and get x bar, y bar. And then tell. Question will be continued little later. Later in dot. So therefore, do one thing. Leave half page gap. Leave half page gap for final conclusion. For final conclusion, leave half page gap. Okay. Now, everything is over. Why? Because for understanding thoroughly, I want once again the solution. Write then write alternate solution. Alternate solution. Right here. Just now we considered origin O at the bottom left extreme end here, see. Then from there we took x right side, y upwards. We got x bar, y bar, see. Now, just to correctly understand, consider origin at the topmost level and extreme right, see here. So now this way is your x. Purpose is to give you more knowledge, that's all, not for time pass, x and y. Okay, I will remove this one now. I will remove, this I will remove. Okay, now this all okay. Now again prepare the table. X from OY, now X is to left side. Y from OX is downwards. So area will remain same. These all will change. I will change it first and then continue because I don't want to waste time calculating each and everything. Okay, start. Don't see this one now. Don't see the previous answer. Start. Figure 1, 2, 3, 4, etc. Over. Area will remain same. Now x distance. See here. This way x for figure 1. 145 plus 200 plus 2d by 3 pi. I wrote the answer. 370.465. Figure number 2. 145 plus half of 200. 3. 2 by 3 of 145. Fourth one, directly center from here, 175 by 2. Fifth also, 175 by 2. Y distance from top, figure 1. Directly, see this way center, diameter is 120 or see the 120, 120 by 2. For G2, 120 by 2. G3, this distance, 2 by 3 of 120. G4, 120 plus half of 110. Fifth one, 120 plus 110 plus 2 times diameter divided by 3 times pi. Now, don't see this one. This is already over. This is the last time answer. Don't see this one. Now, once again enjoy. Calculate x bar this way and y bar this way. You will get this answer. Okay, now I will give information for you. Everything is over. See, now final presentation for both solution. But actually make a note. Later, when you go for moment of inertia, at that time, x bar, y bar, you have to enter here only, not somewhere else. I'll make a note here now. I'll forget, I'll rub this one now. See, 165.9, I'll make a note here. Actually, the answer is there. 165.911 left side and 130.677 down. 130. Not 67 down. No, it's actually not 67, not 67 because, 1 minute, it is not 67. Otherwise it do not tally. Not 67 down. Not 7 3 10, 6 1 7 3 10, 1 4 5. Correct, okay. Now, I will remove this one now. See, what I will do is, see, now you should make a note. Suppose the question is, see, correctly. Locating only centroid. Then you write the given lamina once again without dividing into parts, original lamina. But if you are going for moment of inertia, use the same sketch. See now, from here we got x bar, how much earlier? 239.087. See, 60 plus 100. It will become what? 60 plus 100 is 160. No, furthermore, 239. 60 plus 170. 60 plus 170 is up to here. 60 plus 170 is, calculate is not working. 60 plus 170 is, what is happening? 60 plus 170. 230. We got 239. And 60 plus 170 plus 30 is 260. Oh, that means it will go beyond this point, little this side. See, it will come somewhere here. Red color, that will be later called, see, here, see. From here, see, This is, I'll remove this one now. Okay. From here to here will be your x bar. You write 239.089 millimeter. Now, suppose you want distance from other side. I think board visible. 1 minute. I'll write here. Let me check the board. Suppose you want from other side. Here there is no place to write. I write upper side. Anywhere you can mark. Yes, available space. Suppose you want from other side. What you can do? If this is 239.089, subtract 405, you will get 165.911. 911. Enter here. Calculated value. Or if you go to second solution, see, suppose you go to second alternate solution, then this x bar you got, 165.911, from subtracting, you get this distance. This all you know it, same way. Y bar, how much? First solution, from bottom edge, 187.433. See, 87.5 is furthermore, plus half of 110. 87.5 plus half of 110 is 55 plus 87.5. That is 87.5 plus 110. G4. 1 nimisha. 87.5 plus 110 divided by 2 is 142.5. That is 142.5. Yes. From here to here is 142.5. But we got 187.433. So little more, but not up to here. See, somewhere here is your axis. See, limo zone 70. Okay. And this is, anywhere you can write here, from the extreme bottom edge, see, extreme bottom edge to here. The pen has got a problem there. Okay. From here, extreme bottom edge up to there, your y bar is 187.433 millimeter. Then if you want from top edge up to here, from total 317.5, subtract it, you will get, where is the answer? 130.067. Then we will call this as x-x axis. Usually this as y-y axis, y-y, and then we will proceed further to find moment of inertia about x-x and y-y. This is centroid G for the entire lamina. This is if you are continuing for moment of inertia. That I will, next time I won't do it, but make a note. But question is only to locate centroid. See, our question is only to locate centroid. If the question is only to locate centroid, this much is not required. This all struggling. What you do is, you write the original diagram, make a note. If the question is to only, see here, now, but when question is only to locate centroid, your final answer, final presentation should be as given below. I'll do one thing, I'll reproduce that sketch and then write. Original sketch. Okay. Now, last closing part, where question is only to locate centroid. See, roughly I drawn, not a very neat sketch actually, somewhat reasonably okay. Very neat sketch I not drawn. Right, see, overall 405 and 317.5. See, now, for first solution, I told you leave a gap of half page. There you write, see, usual statement, therefore, centroid G will be as shown in figure below. Okay, mark. See here. X bar we got from here, see, from this reference axis, x bar we got 239.089, 60 plus 200, 60 plus 200, 260. 60 plus 170, 230, slightly after this point, okay, 239. And if you want from other side, from 405, subtract it and get it. And y bar from here, we got 187.433. I already told you how it comes here. If you want from other side, from total 317.5, subtract and get. Okay, now for solution 2, no gap for solution 2 or alternate solution, what I wrote just now, then this will be your y bar and this will be your x bar. This is your x bar. Whereas these two are calculated. That much common sense is there. See, we see there, x and y are not here. See, x this way and y this way. Origin here. Okay. Both the sketch you draw to understand, right? Once you solve, actually, as soon as you finish the first one, you prepare that sketch. And as soon as you finish second one, prepare the sketch. This is to present centroid location. But if the question is to find moment of inertia, we won't write the sketch. We will enter the or mark the centroid in that big sketch only, neat sketch only, because we have to proceed further to find moment of inertia. Okay, that lengthy question, but important. So many questions I will solve. I told the reason. This course will cover each and everything. Some will tell, sir, practically where you require. If practically not required, knowledge point of view required, learning point of view. You would understand, work out. See, little time you spare. Use little spine. See your level of knowledge. You get the very firm grip in structural engineering. Everything counts in structural engineering. Every concept, if you understand thoroughly, as I continue, one fine day, see where you stand. You see there, where you stand one fine day. Oh, you want to compete with me? Okay, thank you. We'll meet in the next class.